July the 8th. Alright, today's goal on the first finish the challenge, and then we go back to yesterday's problem. And then go through the top-down approach and trying to see where do we not get it right. Or maybe we can try a top-down approach ourselves and see if it works using this kind of new way of thinking. But first things first, jump game, that's today's thing. You're given a zero-indexed array and integer k. You're initially standing at index 0. In one move, you can jump at most k steps forward without going outside the boundaries. That is, you can jump from index I to any index in the range of this inclusive. Yes. You want to reach the last index of the array. Your score is the sum of all jumps nums j for each index j visited. Return the maximum score you can get. So for this one, you can choose to jump forming this, and this, and this, and this. Understandable. For this, you can jump, yes. And for this, you can delete this 0. All right, this is like very obvious what type of method need to be used in this one. It's DP again, and let's see. Can we find the correct relationship, the state, right? Find the correct state. So what we want to find is the maximum score when you reach a certain thing, right? When you reach the end, you want a maximum score with the condition of the way you can jump. So what we can say, because you can jump anywhere within, so we just have a maximum range you can jump, right? There's just a maximum range you can jump. So I say to jump, to get to the last one, right? Let's just say 1 minus 1, minus 2, 4, minus 7, and 3. I want to know, to jump to the last one, what is the largest? And then to reach this last one, I can go from minus 7. I can go from 4. That's only 2. So I just need to find the maximum among these two. And then plus 3. Right? And that's it. And then need to find minus 7. And then need to find 4. And then blah, blah, blah. You can go like that. So what we can do to do this, I always like top down, so I'm going to go top down. So the question should be some DP. I'm going to call for the last one. Now we're going to go back. Okay, I need to reach this. I need to find the maximum of these two. And for these two, all the way down to the first one. And we start from here, right? We start from here. And so whenever it's this, the score is 1. Okay, so we can try. We can commit yesterday's and then make it today's. Did I not commit on one of the occasions? No, it was right. It was right. Okay, so yeah, I decided like for sure, just always top down. Bottom up is cool, but it's always difficult to do. So we're gonna go where are you cache. All right, so we're gonna say DP index return an int. Whatever it is, we're gonna return DP n minus 1. And what is n? N is length on nums, right? Okay, so we say if index is equal to 0, then return nums 0. That's the edge case. Otherwise, we are just gonna go from index moving backwards, right? So I'm gonna say for I in range from index minus 1 all the way to index minus k, right? 1, 2 minus k, and have to be the maximum of this 0 minus 1 minus 1. So that's all the i's I can take. And then I'm going to just do max result. No, not max result. Come on. dp. So we're going to call dp on I, and I will want to find a maximum among them. And I'm going to return this. And finally, we're going to do your cache. Now we're going to try the test cases. We have pretty rich test case for this one. We have 1 answer is 7, 2 answer is 17, and 3 answer is 0. Okay, so what we can do, we can say v L, do this. Huh? It didn't work? Oh, shoot. T this. There we go, now it works. Okay, so this will be nums and k. This is max result. Try it. Oh, that is not correct. That is not correct. Madre mia. What is that? So you can pass in this and index -1, -2, right? And I say, I go from here to index -k. So we go here. So for each one, I'm trying to find this. I'm trying to find this. The maximum. Oh, I forgot a plus. I forgot a plus. Maximum of this plus nums index. There we go. Now we pass. Okay, maybe we can carry this on. Let's not be too hasty. Let's do this. I don't care. Okay, submit this. Uh-oh. I think we have a wrong answer. Some edge case. Oh, I am surprised. Huh. I'm very surprised. Man, I've been having this problem. Yesterday is also lots of time exceeded issue. Okay, how about we want to find a maximum? You're saying we can skip a few things? I mean, I cached everything and it's still not working. Maybe I need to build from the start. So the first one I know, right? So for the second one, the only way to reach here is from the previous one, right? So for this one, I can reach from here and here, so I can compute. You know what? I don't know why this is timing out, but let's make a note. So this is TLE. Let's try bottom up. I feel like it shouldn't, right? I feel like it shouldn't. And we can call dp equal to, I don't know, 0, okay? times nums, right? And then you can say dp0 will equal to num0, right? And then for I in range 1 to n, for each one, oh, I see. This will be O(n) squared, right? Because not O(n), it's O(n) times k. O(n) times k. Oh, that's what is not good. Okay. What are you suggesting? Man, all I need is the max value in the previous it's like a sliding window, all right? For each one, I just need a maximum in the previous sliding window. How do I keep that? So I can push one in and pop, but how do I pop? So how do I keep the maximum in a range? So I can have the maximum value, okay? And then I push it in. Then how about the value getting out? I mean, what I can do is if they raise up to the top, I just kick them out. You know, that one can work. It's a heap, right? It's a max heap, and then as I move forward, new value gets pushed in, and then old value can stay in there. It's fine, as long as the top is within the range. Okay, so we're gonna use heap. So we have dp is fine. Main heap is gonna be num0. That's the initial. That we don't even need this. But we need two things. We need this and your index. Okay, so we don't need this. And then we just say for I in this, right? And minus main heap, max heap. Come on, max heap. We want max heap. So from this to this, and then for each one coming out, I want to find the maximum on the previous heap. And we just say while max heap top one is outside. So if it's smaller than current I minus k, so that's the range, right? I minus k is a range, but we know max of this and 0. While this is this, we say heap q dot heap pop max heap. So we just pop until we cannot pop anymore, and then this is what we have. Then we have a result, and then minus math.inf. Right? Then we say res equals maximum res max heap 0 0. And of course, it has to be negative of this plus nums_i, the current one, right? And once I get that, so I'm done. Now we just say heap q dot heap push max heap. What do we push? Minus nums_i. And then we return res at the end. All right, let's see solution 2. not correct. Math is not defined because I haven't imported yet. So import math. Oh, what's the problem now? Oh, of course. These are coding errors. All right, I'll pass 1 and we fail. Answer 17. Result is 14. Okay. So if we can just pop it out. Not pop it out. We just do this. We add it, and that's the new. Oh. So this is the maximum so far, right? No, the maximum so far is that one. So when I say current max, this is the current max. Like including me, if I am jumping into this, what is my max? And then this is the one I'm pushing. Current max, push inside, and then rest equals to maximum rest and current max. Try this. Okay, we have one more test case didn't pass. What happened here? Yeah, for current I need to find a maximum that's in it, right? And then, because I'm reaching myself, so the only thing that could be wrong is this. So we say if the indice is outside, right? If it's outside, I minus k. So minus 1, minus 2. So if it's outside, that means I cannot reach. It doesn't feel right to me, but okay, debug. Let's debug. How do we debug? What we can do is print current max, print I, and then current max. That's how we debug. Oh, you don't do that. Oh, you just get a current max to push it in, and then I see. What am I doing here? We don't do this. We don't do this. We just do max heap minus max heap 0 and 0. Oh, wait. I know. We have to. It's not. It's the last one. No. It's the last one. Current max. There we go. Current max. There we go. Okay. And we need to try this one. All right. See if it times out. It shouldn't. Current max referenced before. Oh, of course. Now, I think, of course, current max is equal to num0. That's the starting, right? That's the starting current max. It doesn't really matter. Doesn't matter. All right, so we can submit this one. I think last time it didn't work is because I probably forgot. Oh, I think it still didn't work. Oh, it did. It worked. But what happened? Did it show me that I finished today's? Yep, it does. 736. 736. 736 days. Wow, the runtime is absolutely horrific. So, there gotta be a better way to do this, right? This is 69 1696. So use a heap to keep track of the max value before in the jump range before the current index. That's O(n) log n. Wow. That's O(n), and we have this. This is a alright, how many times you have to do this? We call it O(n) log n, but it should be a bit larger than this. And it didn't work very well. Which means, based on what we had last time, we shall be able to get it down by half. What are we doing here? We're extending, we're removing, extending, removing. And how do we find a maximum? How to solve? Almost.
For the archaic main rewards, don't even verify that you did the social media stuff. You just click on it and say press confirm.
That's it?
No.
So you did that?
Yeah. Well, you have to click on the link. Then it'll take you to their social media page. But then when you go back to the community rewards, you just click confirm. And for Snapchat Friday, you have to enter the code today, Friday, before midnight. You got the reward. The code is July.
Did you do it?
Yeah. But I don't have Snapchat, so you can also see the code on Instagram. So I went to Instagram and saw the code.
Awesome.
So I enter July today before midnight.
Okay.
It's called the Snapchat Friday.
Snapchat Friday.
And you should wear a face mask.
Yes.
Why didn't you wear it?
I'm gonna wear it right now.
Why didn't you wear it?
I forgot.
for the Twitter page. You click on a link that says Twitter says the account has been removed because it violated some terms of service.
Your account?
No, Park Kylie.
Oh my god. So they don't have a Twitter account anymore.
I think it's because you would get points. Because on the Facebook one, there's no points for liking on Facebook. So because of Facebook's terms of service, no points are awarded for this or something.
So very soon Twitter will be the same.
But I still get the points because you just click confirm.
Alright. Okay, left. Roll. Alright, I actually have no clue, so I'm gonna just take a look at my solution back more than a year ago. I'm gonna try this one. This is probably my first one, and this, and of course, open this. There is a likelihood that they increase the number of test cases. That could be the reason if the solution appears to be the same. That was only 6 test cases passed. Terrible. 65, so they have 6 more test cases. Okay. This is a heap. Yes, that's exactly what we're doing. And actually, I did it better this time because I don't have to do the extra step. So I think it's the same. Back then, 65 test cases. This is probably speedy version of solution 2. Oh, look at that. Huh? I have indices. Okay, so I just popped indices. And then current, what is current? Equals numsize current one plus scores indices is 0. So the front. We say, well, indices and scores indices minus 1. So the end of the indices is smaller than the current, then we indices dot pop. So we pop, 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 pop. And score I equals to current. Wait, what is this trying to do? It's just, I will always use indices 0 to the front, right? I always use the front to give me the current value. And then I have the previous scores compared to the current value. If it is smaller than me, then it can be gone. But if it's bigger than me, then it remains. Why is this one faster? Oh, shoot. In the gym was a little. Yes. Alright, I'm back again. Trying to figure out what does it mean. It's a mono Q. Monotonic Q. Huh. What do we want to find? We want to find the largest in this, right? So let's say if we keep a monotonic Q, and if we can keep the biggest one in the front, which means if we had a new one, if we always assume the biggest is at the front, and then the new one we add it, and then we start pushing into the Q. Monotonic stack, pushing into the stack. If it's smaller than me, then just pop, 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 pop. Eventually I would, oh, I see the trick. Yeah, monotonic. I didn't think about it last time, nor did I think about this time. Monotonic stack to keep the largest value at the front, the left of the window. And we use a yes from collections we used a deck. Haven't used deck for a long time. So we say mono stack equals a deck, actually num 0, this front, and then you know what? I'll do this 0, right? And then current max equals num 0 for I in range 1 to line nums. Okay, and we say if a while mono stack 0 1 is smaller than I minus k, then mono stack dot pop left. Okay, and then current max shall equal to nums I plus mono stack 0 0, and then while mono stack and mono stack minus 1 0 if it's smaller than current max, then mono stack dot pop. Once we're done, mono stack dot append current max and I. So we're gonna return current max. Let's try number 3. Yeah. So because it's monotonic, so we can actually call this ON, which I hope this one will be faster. Monotonic. But it is 71, so we have a lot more test cases than last time. I run this one as well, but we have a big test case here, which is good. I think this is clearer than the previous solution. Oh, ooh, look at this. Madre mia. Okay, that's good. Monotonic. Now I was trying to see how to, how to keep the largest value. We can use a monotonic stack to keep the largest value. In a sliding window, it doesn't really matter. Hold on. You give a certain it works because the size is static, right? It's a static. So you push in. So everyone will be at least pushed once, or popped once. Yeah. Yeah, like if you want to find in a stream, right, to keep the largest value in the stream. Because, yeah. Yeah, it's a good problem. Keep the largest value in a stream. A monotonic stack, because it's always on front. And the worst case will just be you pop everything out, right? So if it comes the largest value, we'll pop everything out. Otherwise, yeah, every value gets pushed in and popped once. So at most is ON, at most. But if you do ON log n, which is heap, if the length is large, then it's not as fast. Okay, so now let's try this again. So what we know is houses, right? So we have a bunch of houses, and so we know the key is the ith house, right, painted the color J and have K neighborhoods. That is the thing. So if we wanted to top down, what we can say is, okay, I'm passing ijk, right? And I say, okay, in the current stage, I will say, what do I say? So I passing this, I want to know, right? I want to know for me, right? I want to know at I, given color j, right? And what's the price? What's the cost? I want to know the cost of ijk, right? And the final one, what we want to know is I is the last one, j is bunch of j, and k is the thing, okay? And then I say, in order to find this, I need to know the previous color. So I need to go I minus 1. Oh, this might have a, hold on, oopsie doozy, what did I do? Okay, so say def dp I, j, and k, right? And this one will return an integer, which is the minimum cost. And of course, we're gonna, you cache this. Oh, and I need to find a previous one, right? Okay, so I want a k, so I want I minus 1, right? So I want to know, and then for my current, if house is I, right? The current one is painted, right? My current one is painted. So if my current one is painted, so I can, the cost will be the same as the previous one, which is dp I minus 1, right? The cost will be dp I minus 1, but it can go bunch of j's, right? It can go bunch of j's. So, okay, hold on. If the house is painted, and then we say if houses j, I is equal to j, is not equal to j, right? Then I return math.inf, which means I cannot paint here, right? I cannot paint here. No matter what, I cannot paint here. Otherwise, if we are the same, right, then we say I want to find dp I minus 1, and then bunch of j's, I don't know, bunch of j's, and the k, okay, the k, it depends, right, depends. So we say, so if k is equal to j, so we can say k minus this is previous color, right? So pj is equal to current color. And then we say for pj in range 1 to n plus 1. So that's the previous color. I have so many color. And it's actually not equal to, right? So if the previous color and the current color is different, then the neighborhood would decrease. If they're the same, it's the same neighborhood. And then we're going to go through all of this to find the minimum among all these. So I'm going to return this, okay? Else, if house is 0, then I can paint. And I can paint all different colors. So I can say No, because I have the current color is J, right? So I can paint J. That's what I'm saying. I can paint J. So if I can paint J, I still need to know all the previous. So basically, the whole thing still works, right? But this is so minimum of this the plus, because I can paint the current J, which is cost I and J minus 1. All right. Again, if the previous is the same, then it's the same, then we don't increase it. Otherwise, we have a decrease. So we're going to return this. And then we're going to return dp. What's I is going to be land houses minus 1. J is going to be J. And this is going to be target for J in range 1 to n plus 1. So we're going to say the result shall equal to the minimum of this, and return res if res is smaller than math.inf, else minus 1. Let's try this. So if I is smaller than 0, return math.inf. That's not working. I thought this was pretty smart. The first one's wrong. Hold on. Ice house, right? And painted color J with K neighborhoods. So what is the cost? What is the minimum cost with that? And what we want to find out is, this is the last house with color J and a target number. What is the minimum? And we have different, okay? And then I say if this house is painted and if J is not equal to the painted color, that just means we cannot paint a color this way. So return math.inf, which means it's impossible, right? So it's impossible. Otherwise, if the two are the same, then we want to find out the minimum cost to reach here. So what I do is I go from all the previous color, because I don't know what previous color do we have, right? I don't know the previous color. So I go through all the possible previous colors, right? And then I put it in here, and then there's the previous one with previous color, and then this is, I need to know the previous neighborhoods, because I want to reach current neighborhood is K. So if the previous color is equal to the current color, or if it's not equal to the current color, then I know the neighborhood needs a plus 1, so the previous is minus 1. Otherwise, it's just K. So I think this is one right. Otherwise, if house is I, right, with current house is a 0, so I can paint the current house. So when I can paint the current house, I say I want to paint it J. Okay, that's what I want to paint it at. Therefore, I need to add the cost painted. Now I need to know the previous, all the previous, what is their minimum cost. And previously, the cost is going to be I minus 1, and previous color, right? And then K minus previous color if it's not equal to J. If it's not equal to the current color, then it has to be minus 1. Otherwise, it's the same neighborhood. And now we go through all this, return the minimum. I don't understand why it is not right. Okay, what do I do about this? Yeah, when inspected. Oh, the K. Oopsie doosey. Target. K must be negative. Okay, so we need to go max of this and a 0. K cannot be smaller than 0. Still not make it any better. Oh, technically K cannot be 0, right? The number of neighborhood. So we say be 1. Nope. Be 1 to target plus 1. Print ijk and dpijk. Inf. Okay. That's not good. So maybe we should address when I equal to 0. Okay, we need to address that. When I equal to 0, if house is 0, when I return 0, else then we're going to return appended as j, right? And a number of neighborhoods. I need to check if it's possible to have that number of neighborhoods. If k is not equal to 1, return math.inf. Otherwise, and then return else cost I and j minus 1. How about this? Equal. Okay, now we have something. Now we have 5, which is not right. Something is still not right. I need to check if it is possible. It's like you can do 3 on a 2. Maybe we cannot do 3 on 2. That's the thing. Everything I have 1, 2, 3, 1, 2, 3, 1, 2, 3, which is not the case. I did not have this check, right? How do I check if it is possible to do? I shouldn't do that. I should just do this. Yeah, I have an idea. Don't max it. We have to review the error. Right? And the same thing. So what we do is if at any time k is smaller than 1, then return math.inf because the neighborhood will never be smaller than 1. And now if I get 0, if k is not equal to 1, we return this. If k is equal to 1, then we return this. Otherwise, we go this. Tried it. Now we pass. Okay, that looks promising. Try the others. Oh, the others don't work as well, huh? It's way too long. Which one is taking a long time? These are pretty fast. Oh, got a wrong answer. Zero. Not 0, it's shoot. If house 0, right? And then, holy moly. If house is 0, then return 0 if j is equal to house is 0. Else, also math.inf. Otherwise, return this. Yep. So the problem now still is with this one. Yeah, it will just take forever for this one to do. Too long. How does this one work? Yeah, it's not working. What did you get from this? Once it becomes infinite, then we don't have to keep going. Yeah, because if at a certain, given a certain color, we hit infinite. How should I say it? I don't know, man. Well, what we can say is, based on the number of colors that we have produced, right? That's a saving. But it can. If I is smaller than k, then we can say, right? So we can say based on I. When I is big, then it's possible that we can go through more. But if I is small, then we cannot go through more. I don't think it will solve the problem because it just can all the way go to k. We can say if k is smaller than 1, k is larger than I. That plus 1, the number of neighborhoods. It's still going to take a while. But ooh! I was just going to say it's still going to take a while, but then it proves me wrong. Maybe that is the case. Oh, wow. I think we found the solution. This is the thing. K smaller than 1 is no-go. K larger than this is no-go, right? And when I is large enough, But remember, this I, how big is this I? Oh, this I is only 100. Ah, this I is only 100. It's not that big. So the actual case where k and I is valid is not that much, right? So k is 100, k is whatever, right? But if it's larger than this, then we, this is important edge cases. And then this is initialization, right? This is a initial condition. Then this is the regular condition. Okay, it's top down. The logic here is much, much easier. Yeah, didn't even see this. I can actually see what type of things are you talking about. It's simpler. Let me submit mine first, and then we take a look. No. No. Ugh. It didn't work. It did not work. Okay. That's fine. This previous color. This one is considered. What's it considered here? I is 0, k has to be 1. Okay. What happened? It's not a big thing. It's only 25. Oh. I feel these are still correct. Maybe just I have two of this. It didn't work. I don't know, man. I don't know. You got me. Wait, what happened? Why nothing is printed out? Alright, it doesn't work here. Nah, it's 08. Just don't do it. So what we want is k is larger than I plus 1, right? So what we say is, gosh, what I'm trying to do is reduce like 11. All of these are inf, right? Okay, I have lots of zero. This one, zero can be avoided. So there's only two situations. One is the two are the same, right? So if the two are the same, you say if the two are the same, J and the PJ, the two are the same. So the two are the same, and then it will be the same K, right? It will be the same K. So it will be dp I minus 1 pj and the same K, right? Otherwise, it will be a different color. It will be a different color. Then I can call it dp. Let's say if it's going to be k minus 1, right? If this, and then it's different color. So at least we need to have 2. Now, right now it's 2, so at least it has to be larger than 1, right? Larger equal to 1. Because it has to be 1. And all I can say is K has to support a 2 and has to be smaller or equal to I plus 1, right? If K is in this range, well, K definitely is in this range because otherwise we won't even call this, right? If K is larger than this, then we will escape. But right now, K need to be smaller or equal to I plus 1. Yeah, K is always smaller or equal to I plus 1. So K just has to be greater than 2. Then return the minimum of res and this. That will be K minus 1. If Pj not equal to J. Otherwise, we can return math.use. So here we'll do the same thing. Still struggling. This is if they're equal, right? Plus cost J minus 1. I don't know. Does this make it better? This is J. Wow. Eight. Yeah, it didn't make it any better. Okay, I don't know. Minimum cost to paint houses I with T neighborhoods where house is color P. It's the same. What are you saying? You're saying it's the same. Zero, target, and a -1. Oh, from left to right. Oh, this is a minus and this is a plus. Target. So I kind of see the benefit of having to make this the previous color, because when you make this the previous color, the current color we actually have. Okay, so I'm gonna adopt that. Let's say this is PJ, this is the previous color. Okay, so if it's the previous color, this I think still works. That's just edge case. This is the initial condition, right? Yeah. This is the initial condition is I equal to 0. Let's color the first house. I would say first house is already colored, right? Then the previous color doesn't really matter. Then we just return 0, right? Because the previous color doesn't matter, so we just return 0 here. Else it's not, then what do we return? Well, it doesn't have a previous color. That should be the minimum. Because we're asking color the first one. Current color in range. Okay, now I is not 0. I is not 0. When we check house, house is this. So current we have a color, right? So we have a color for the current. Then what do we do? So for the current house, we have a color, so we don't paint it. So it'll be the same as, we can say just return, same as previous, which is so I want to know is this with the previous is PJ, with previous is PJ, what is the cost for the current, painting the current, right? With the previous is PJ. So I know the previous is PJ. I want to know what is right now. So if it is this, then right now the cost shall be with previous is PJ. It still doesn't work. with previous is PJ. It doesn't make any sense. Doesn't make any sense. Why is my idea doesn't work? I don't know why it doesn't work. This one doesn't seem to be any more special than this. I'm gonna go back to the old solution. I just want to understand, honestly. I just want to understand why this doesn't work. Because it doesn't make any sense to me. There's not that many things to go through. It's 25 times 12 times 15. How big is that? It's only 4,500. Unless I'm repeating stuff. Otherwise... Unless I'm jumping back and forth. But that won't work. Gotta be kidding me. Oh, you gotta be kidding me. You gotta be kidding me. Don't do this. This is too cruel. The one time the one time I tried not pulling that, and you're pulling this crap on me, it exceeds the maximum cache. It exceeds the maximum cache. That's why it never hits. Yeah, that was like, I don't see any problem in this one. And then we can also remove this because we already considered, right? And then we can say if this, I return this, I return this, and this is the initial condition, and this is this, right? And if it's not, I'll always do this. Yeah. All right, here we go. Yeah, okay, M and K. Okay, that's it. That's it. I'll see you guys tomorrow. Adios.